steam is then used for generating electricity. So that is a boiling water reactor. Now, what is a breeder reactor? Of course, breeder means something that breeds. Breeds what? Well, a reactor uses fissionable material as the fuel. If it is called a breeder reactor, probably it means it breeds more fissionable material. So a breeder reactor will produce more fissionable material. Well, how can that be done? Under appropriate operating conditions, the neutrons given off by fission reaction can breed more fuel from otherwise non-fissionable isotopes. Well, I told you that most of the uranium that is available naturally is non-fissionable uranium-238. And remember, the fuel that is used in the nuclear reactor is not pure fissionable material. It is enriched uranium. That means if naturally occurring uranium contains, say, 0.1% of the fissionable material uranium-235, enriched uranium will contain about 15% of uranium-235. The rest are all non-fissionable uranium-238. So when you look at a fuel rod, most of the fuel rod is non-fissionable uranium-238. Only a small part of it is fissionable U-235. Now, in a breeder reactor, you can actually make that uranium-238, which is otherwise non-fissionable, into fissionable material by making it radioactive. Now, how is that possible? You know that when a radioactive nucleus emits a beta radiation, the atomic number increases by 1 unit. That's right. So, if uranium-92 can be made to emit a beta, it will become an element of atomic number 93. Now, if that again emits a beta, it can produce an element of atomic number 94, and that is plutonium. And plutonium is a readily fissionable material. Now, this is how it happens. Uranium-92-238, a non-fissionable isotope of uranium, absorbs a neutron, becomes uranium-239, and uranium-239 emits a beta. What happens? Uranium-239 emits a beta. What is the resulting element? The resulting element will have one atomic number 1 unit greater and the same mass number. What is the element that is 1 unit higher than uranium? It is neptunium. So it's neptunium-93-239. Now, this neptunium-93-239 is again beta active. It will emit a beta radiation. The result is an element 1 unit higher than neptunium, which will be plutonium-94-239. Now, this is the process. So when you have a fuel rod that contains large quantities of this non-fissionable material, now they will be absorbing neutrons and undergoing this degeneration, producing plutonium in there. That means you are actually producing more fissionable material. That is a breeder reactor. So the most common breeding reaction is that of plutonium-239 from the non-fissionable uranium-238. As I explained, uranium-238 absorbs neutron and becomes beta active. It emits 2 successive beta particles and become a nucleus of plutonium, a very readily fissionable materials. Now the reactor core consists of thousands of stainless steel tubes containing a mixture of uranium and plutonium oxides, about 15 to 20% fissionable plutonium-239. Surrounding the core is a region called the breeder blanket, consisting of tubes filled only with uranium oxide. Now, such a reactor can produce about 20% more fuel than it consumes by the breeding reaction. Now, why is the big controversy about the uranium reprocessing by Iran? Well, when you reprocess the spent fuel, when you take out the fuel rod that has been used, remember that contains large amounts of plutonium which is readily fissionable. Now a reprocessing plant is a place where you take these spent fuels and remove that fissionable plutonium from it. And if you can do that systematically, you can build large amounts of fissionable material. So when a country builds reprocessing plant, there's only one thing that can come to your mind. Why are they doing it? They are building stockpiles of large quantities of fissionable materials. Why? The only intention will be to produce bombs. So if Iran is having a nuclear reprocessing plant built, recently there was mention of a secret reprocessing plant that has been discovered. And now there is talks that Iran, instead of using their reprocessing plant, they will send these materials into Russia to reprocess so that they will produce these materials which can be then used for medical purposes and not for making bombs. Well, I hope some of you at least are following some of these processes that are taking place in the world in the realm of nuclear energy. Now it's very important because the survival of mankind itself will depend on how closely we can keep this without getting into the hands of terrorists and other organizations. Well, that's an animation of actually what happens. Uranium-238 becomes uranium-239, emits a beta and becomes neptunium-239. It will emit a beta and finally becomes plutonium-239. So watch that carefully one more time. Uranium-238 becomes uranium-239. Emits a beta, becomes neptunium-239. Emits a beta, becomes plutonium-239. All right. I think that sort of explains itself.